What's up everyone, welcome back to LaithChem. This is part 4, our final video for chapter 1, and today we're tackling the big one, redox reactions, reduction and oxidation. These are reactions where electrons are physically transferred from one atom to another. Now here's the big idea. Up till now we've mostly looked at reactions where atoms rearrange themselves. Redox reactions are different. In these reactions, electrons actually move from one atom to another. Whenever electrons move like that, the oxidation state of those atoms changes. That's really what redox is all about. One quick notation thing before we go any further, because this trips people up all the time. Oxidation states are written with the sign before the number. So +2, -1, +7, etc. Ion charges are written with the sign after the number, so 2 plus, 1 minus, as you see in formulas. These look similar, but mean slightly different things, so in redox chemistry we use oxidation states. Pay attention to which notation you're seeing on the exam. Now, before we can talk about what's being oxidized or reduced, we need to be able to assign oxidation states. There are only a handful of rules you actually need to memorize, and fortunately, they're pretty straightforward. Now, first rule, if an element is by itself, or not bonded to anything else, the oxidation state is always 0. Next rule, if you're looking at a single atom ion, the oxidation state is just whatever the charge is. Rule 3, fluorine in a compound is always -1, no exceptions. Fluorine is the most electronegative element in existence, basically making it the biggest electron hog on the periodic table. Rule 4. Oxidation in a compound is usually -2. The exception is in peroxides, such as hydrogen peroxide, where it's -1. Rule 5. Hydrogen in a compound is essentially always +1. There are exceptions, but you won't be expected to know them unless you plan on studying chemistry more in depth in college. Now, there's one last rule that honestly does most of the heavy lifting. The sum of all oxidation states in a neutral compound must equal 0. In a polyatomic ion, the sum must equal the ion's charge. This is how you find unknown oxidation states algebraically. Here's the most important memory trick in all of redox chemistry, oil rig. Oil stands for oxidation is loss of electrons, and rig stands for reduction is gain of electrons. Now, when an atom is oxidized, it loses electrons. When electrons leave, the oxidation state increases. It becomes more positive. When an atom is reduced, it gains electrons, so the state decreases. It becomes less positive. So look at the example. 2 sodium solid plus chlorine gas yields 2 sodium chloride. Watch what sodium does here. Sodium goes from 0 elemental to 1 in sodium chloride. That's an increase. Sodium is oxidized. It lost an electron. Chloride goes from 0 in chloride gas to -1 in sodium chloride. That's a decrease. Chlorine is reduced since it gains an electron. One thing that's impossible in chemistry, can't happen at all, is oxidation happening by itself. You can't have oxidation without reduction. If electrons leave one atom, they have to go somewhere, to another atom. Hence the combined name, redox reaction. Now, if there's one vocabulary question the AP exam loves to ask, it's this one. The reducing agent is the thing that gets oxidized, and the oxidizing agent is vice versa, the thing that gets reduced. Yes, I know it's backwards, but here's how to think about it. The reducing agent causes reduction in something else. To do that, it donates electrons, which means it gets oxidized. Think of the reducing agent as the generous friend you have. It gives away electrons to everyone else. Since it gives electrons away, it ends up oxidized. The oxidation agent causes oxidation in something else. So to do that, it accepts electrons, which means it itself gets reduced. So what's being oxidized is the reducing agent, and what's being reduced is the oxidizing agent. From our sodium chloride example before, sodium is oxidized, meaning it's the reducing agent. Chloride is reduced, making it the oxidation agent. Now, this is a classic AP multiple choice trap where they'll ask you which species is the oxidation agent, and students obviously pick the one that's oxidized. Wrong, it's the thing that causes oxidation. I'm letting you know now so you don't lose points on the exam. Remember it by the reducing agent is the one doing the generous thing. Alright, now this is probably the most complicated thing we've done in chapter 1. But don't worry, don't panic, I'm going to walk you through it. If you follow the same 7 steps every time, these problems become surprisingly manageable. And I'm going to walk you through each step, and we're going to do a full example together. Now here's the approach. First, you want to identify the 2 half reactions, one for oxidation, one for reduction. Split the overall reaction into the species that's losing electrons and the species that's gaining electrons. Next, balance all atoms except hydrogen and oxygen first. If you have iron 2 iron 2 ion, that becomes iron 3 ion, that's already balanced. If you have permanganate ion, that becomes manganese 1 ion, the manganese is balanced, or one on each side. Then, balance oxygen by adding water molecules to whatever side needs oxygen atoms. Remember, we're in acidic solution in this example, so we have water and hydrogen ions available. After that, balance hydrogen by adding hydrogen ions to whichever side needs more hydrogen atoms. Then, balance the charge by adding electrons to the more positive side. The total charge on both sides must be equal. When that's done, multiply each half reaction by whatever number makes the electrons in both half reactions equal. We're about to add them together, and the electrons need to cancel. Finally, like I just said, add the two half reactions together. Cancel everything that appears on both sides, which is usually hydrogen atoms, water, and the electrons. Alright, here we go. Now let's do an example where we're balancing permanganate ion plus iron 2 ion, yielding iron 3 ion plus manganese 2 ion. Now, step 1. Identify oxidation and reduction. Manganese and permanganate ion is plus 7. Manganese and manganese 2 ion is plus 2. That's a decrease, so that means manganese is reduced, making it a reduction half reaction. Iron in iron 2 ion is plus 2, and iron 3 ion is plus 3. So that's an increase, so iron is oxidized. Oxidation half reaction. Step 2. Write the half reactions. For reduction, permanganate ion becomes manganese 2 ion. For oxidation, iron 2 ion becomes iron 3 ion. Step 3. Balance the non-hydrogen and non-oxygen atoms. Manganese is already balanced and iron is already balanced, so we don't need to do anything here. Step 4. Balance oxygen, or add water. So permanganate ion has 4 oxygens. Manganese 2 ion has none. So you add 4 moles of water to the right so that the permanganese ion yields manganese 2 ion plus 4 H2O. Step 5. Balance hydrogen by adding hydrogen ions. We now have 4 times 2 equals 8 hydrogens on the right, so you have to add 8 hydrogen ions to the left so that the permanganate ion plus 8 hydrogen ion yields manganese 2 ion plus 4 water. Step 6. You want to balance the charges by adding electrons. Now the left side charge is -1 plus 8 times 1 equals 7. For the right side, 2 plus 0 is 2. The difference is 5 here, so you want to add 5 electrons to the left so that the permanganate ion plus 8 hydrogen ion plus 5 electrons yields manganese 2 ion plus 4 water. Yes, it's a mouthful. Both sides here, though, are plus 2. For the oxidation half reaction, iron 2 ion yields iron 3 ion plus an electron. It lost an electron, so you have to add one to the right. Step 7 is to equalize the electrons. Now both half reactions have to exchange the same number of electrons. Oxidation makes 1 electron. Multiply oxidation by 5. 5 iron 2 ion yields 5 iron 3 ion plus 5 electrons. Step 8. Add the half reactions. Permanganate ion plus 8 hydrogen ion plus 5 electrons plus 5 iron 2 ion yields manganese 2 ion plus 4 water plus 5 iron 3 ion plus 5 electrons. Cancel the 5 electrons on both sides, so finally you get permanganate ion plus 8 hydrogen ion plus 5 iron 2 ion yields manganese 2 ion plus 4 water plus 5 iron 3 ion. Let's check the charges. On the left we have -1, 8, and 10, which makes 17. On the right we have 2, 0, and 15, so 17. Both are balanced. Your turn. Now let's see if you can handle this one on your own. This one is a bit more complex, since arsenic oxide has 2 arsenic atoms, and you'll need to deal with some tricky balancing. Pause the video and try it. Come back when you're ready, and I'll walk you through the full solution. Alright, and I hope you guys all have the answer. Now here we go. So step 1, you want to identify oxidation and reduction here as well. Arsenic and arsenic trioxide goes from +3 to +5 in arsenic acid. That's an increase, so arsenic is oxidized. Nitrogen and nitrate ion goes from +5 to +2 in nitric oxide. That's a decrease, so nitrogen is reduced. Step 2, you want to write the half reactions. For oxidation, arsenic trioxide becomes arsenic acid. For reduction, nitrate ion becomes nitric oxide. For step 3, we want to balance the non-hydrogen and non-oxygen atoms. For oxidation, there are 2 arsenic atoms on the left, so we put a 2 on the right. Arsenic trioxide yields 2 arsenic acid. For reduction, nitrogen is already balanced, so we can skip this one. Step 4, balance oxygen by adding water. For oxidation, left has 3 oxygens, right has 8, or 2 times 4. So you want to add 5 water on the left, so arsenic trioxide plus 5 water yields 2 arsenic acid. For reduction, the left has 3 oxygens, the right has 1, so you want to add 2 water to the right. Nitrate ion yields nitric acid plus 2 water. Step 5, balancing the hydrogen by adding hydrogen ions. For oxidation, left has 10 hydrogens, or 5 times 2. Right has 6, or 2 times 3. So you want to add 4 hydrogen ions to the right. Arsenic trioxide plus 5 water yields 2 arsenic acid plus 4 hydrogen ion. For reduction, the right has 4 hydrogens. Add 4 hydrogen ion to the left so that nitrate ion plus 4 hydrogen ion yields nitric oxide plus 2 water. Step 6 is to balance the charges by adding electrons. For the oxidation, the left charge is 0, the right charge is plus 4, so you want to add 4 electrons to the right. Arsenic trioxide plus 5 water yields 2 arsenic acid plus 4 hydrogen ion plus 4 electrons. For reduction, the left charge is negative 1 plus 4, so 3, the right charge is 0, so we want to add 3 electrons to the left. Nitrate ion plus 4 hydrogen ion plus 3 electrons yields nitric oxide plus 2 water. Step 7 is equalizing the electrons. Oxidation produces 4 electrons, reduction uses 3 electrons. The least common multiple here is 12. So we multiply oxidation by 3. 3 arsenic trioxide plus 15 water yields 6 arsenic acid plus 12 hydrogen ion plus 12 electrons. For the reduction, you want to multiply it by 4, so that 4 nitrate ion plus 16 hydrogen ion plus 12 electrons yields 4 nitric oxide plus 8 water. Step 8 is to add the half reactions and cancel the common terms. So cancel 12 electrons from both sides, cancel 12 hydrogen ion from the right, leaving 4 hydrogen ion on the left, or 16 minus 12. Cancel 8 water from the right, leaving 7 water on the left, or 15 minus 8. For the overall balanced equation, 3 arsenic trioxide plus 4 nitrate ion plus 4 hydrogen ion plus 7 water yields 6 arsenic acid plus 4 nitric oxide. Checking the charges, on the left we have negative 4 plus 4 to get 0, and then on the right we got 0, so it's balanced. Okay, so the good news is that balancing in base isn't a completely new method, and you follow the first 7 steps for acid, and then there are a few extra steps. So extra step 1, you want to count how many hydrogen ions are in your final equation, and then you want to add that same number of hydroxide ions to both sides. You're adding hydroxide ions to both sides to neutralize the hydrogen ions. Extra step 2, on the side where hydrogen ions and hydroxide ions meet, combine them. So hydrogen ion plus hydroxide ion obviously makes water. Now rewrite that side with water molecules. Now the extra step 3, you want to simplify. You'll probably have water on both sides now, so cancel the H2O molecules that appear on both sides. The reason we do this is because in basic solution, hydrogen ions don't really exist in significant amounts. By adding hydroxide ions to cancel the hydrogen ions, we're converting to a form that makes chemical sense in basic conditions. And with this, we've officially made it to the last problem in Chapter 1, I promise. This one is in base, and I know we haven't done an example together yet, but I believe in you guys. Just remember the 9 steps. You can skip back to the 9 steps if you need to, but try it on your own. Alright, now I'm not expecting all of you to have gotten it right, but hopefully you did your best, and now we can go through it together. So, step 1, identify oxidation reduction. Silver goes from oxidation state 0 in elemental silver to +1 in the ion. That's an increase, so silver is oxidized. Oxygen in oxygen gas goes from 0 to -2, which ends up as hydroxide ion in base. That's a decrease, so oxygen is reduced. So step 2, we write the half reactions. For oxidation, silver metal plus cyanide ion yields dicyanoargentate ion. For reduction, oxygen gas yields hydroxide ion. For step 3, balance non-hydrogen and non-oxygen atoms. For oxidation, 1 silver and 2 cyanide ions are needed for 1 dicyanoargentate ion. So silver metal plus 2 cyanide ion yields dicyanoargentate ion. That's really hard to pronounce, by the way. I hope you guys can give me the benefit of the doubt here. For reduction, oxygen is the non-hydrogen atom here. We have two oxygen atoms on the left, so put a 2 in front of the hydroxide. Oxygen gas yields 2 hydroxide ion. Step 4, balance the oxygen by adding water. For oxidation, no oxygens are involved, but for reduction, the left has 2 oxygens and the right has 2 oxygens. So in basic solutions, we balance hydrogens and oxygens together using water and hydroxide. So we also don't have to do anything here. Step 5, balance hydrogen and oxygen for basic solution by adding water and hydroxide. For oxidation, it's already balanced, and for reduction, to convert oxygen gas to hydrogen ion and base, add 2 water to the left and adjust to 4 hydroxide ion on the right. So oxygen gas plus 2 water yields 4 hydroxide ion. For step 6, we want to balance the charges by adding electrons. For oxidation, the left side charge is 2 times negative 1 is negative 2. So the right side charge is negative 1. That means we have to add 1 electron to the right. Silver metal plus 2 cyanide ion yields dicyanoargentate ion plus an electron. For reduction, the left side charge is 0. The right side charge is 4 times negative 1, being negative 4. Add 4 electrons to the left. Oxygen gas plus 2 water plus 4 electrons yields 4 hydroxide ion. Step 7, equalize electrons. Oxidation produces 1 electron. Reduction uses 4 electrons. Multiply oxidation by 4, so 4 silver metal plus 8 cyanide ion yields 4 dicyanoargentate ion plus 4 electrons. You keep the reduction as is. Oxygen gas plus 2 water plus 4 electrons yields 4 hydroxide ion. Step 8, add the half reactions and cancel common terms. Cancel 4 electrons from both sides, and after that, the overall balanced equation should be 4 silver metal plus 8 cyanide ion plus oxygen gas plus 2 water yields 4 dicyanoargentate ion plus 4 hydroxide ion. Checking the charges, on the left we have 8 times negative 1, which gives us negative 8. And on the right we have 4 times negative 1 plus 4 times negative 1 again equals negative 8. So our last problem is balanced. And with that being said, that's a wrap on chapter 1. Now I know there's been a long break between this video and my last one. It's just been a busy time, but I should be back Tuesdays and Fridays. You know where to find me. You've now covered solutions and molarity, precipitation reactions and solubility rules, acid-base reactions and titrations, and redox reactions with balancing. Now this is one of the most content-heavy chapters in AP Chem, I know, even though it's the first one I'm covering, so just be proud of yourself for making it through the first one. Now, if you found these videos helpful, drop a like because it really helps other students find this channel. Subscribe for more AP Chem content coming up Tuesdays and Fridays, and stay tuned for the next chapter we're covering soon. I'll see you in the next one, and again, thank you for watching.